Okay.
Yeah, very good. Okay, hello everyone, and welcome to today's short introduction into SPECCHIO. And what I'm gonna talk about today is first I'll introduce why we need this, then a little bit about how the system works, and then we'll have a look at some recorded videos that show how you use the graphical user interfaces and practical applications of that system, and hopefully it'll help you at some point to concentrate on your research and not only on data management, but more on the research part. So let's go with that. So I think that the reason why we've got these systems is, I quickly figured it out myself. We've got a lot of data, and you usually are spending a lot of time looking for your data. And so these systems are information systems that store the spectral information and metadata in a database, and then give you a search interface or an interaction interface to work with these data. So what are we trying to solve here? The first one is, where are my data files? Usually you've got a lot of them, so it gets harder and harder to keep track, and you spend a lot of time collecting them, and therefore not really knowing where they are and why they were recorded is a problem. Usually you might forget, or other people might not know the sampling context and the conditions. You might also find that maybe your instrument, despite it costs about as much as a little car, is actually not producing the truth. So data quality is an issue. And finally, sharing data is really hard. And we'll see what we need to do in order to amend this. And so the key to data usage over long term, and in particular also data sharing, is metadata. And this is a really nice graph which goes through the different stages of how much you know about your data and metadata. And over time, this information gets lost, in particular after someone retires or even dies. This is the end of it all, and one should look into ways to conserve that information for future use. So in fact, the metadata is equivalent to contextual awareness. The metadata should help you to understand why spectra were recorded and how they were recorded. How do we do this? This is the current architecture. We've got a server and a user end. On the server side, there's this Glassfish application server and the web server, and this shields the spectral database from direct interaction by users. On the client side, there's a variation of tools you can use to interact with that system, which is, the first one is a web browser interface, which is quite simple. I personally so far don't see why this is really helpful, apart from a quick search, because you don't have to install anything. But if you really want to work with all the functionality of the system, this is through a Java application, and you can use the pure Java app, or you can use that part of this Java application and embed it in higher level languages, so like Python, MATLAB, and so on, and use it as a programming access. This is the spectroscopy life cycle, and it shows which parts of the life cycle are currently covered by the information system. So it goes through reading the data, adding metadata, to processing, and retrieve. And a few key points. So like the first one, data ingestion must be automated as much as possible. And the same thing is also true for adding metadata in a kind of streamlined fashion. Data processing, the goal is that you don't have to import, export data all the time to the file system. You do a processing which I call database-centric processing. And if you do that, you keep all the metadata in the system and carry it along. And we'll see how that works. You can search the whole system by just going through the metadata and adding constraints on whatever attribute you want to set. So this is the goal, maximize the research time and sort of work on your data and not try to find these things on the file systems. So what you do, and you might see my mouse moving now, spectral files are being read either by the SPECCHIO application or by your own kind of code. You insert it into the database, then you keep adding meta information, you do select and search of data, and finally, oh yeah, there's a little pop-ups here, what I was just saying. So like this part where you do a data search, this can be like through the graphical user interface, or you can also program it in MATLAB, R, or these languages. So you can, as we will see later on, you can start to combine the graphical user interface and programming. And finally, data analysis. It's best done in high level languages, and you just use the database system as a data source. So let's have a look at a few of the results. So we're going to have a look at the practical use and how you can install it and where the code is. Maybe a question you guys got is supported file formats. There's a whole list of the supported formats online, and there's the link. And I've also got examples of these files online. If you've got an instrument we don't cover yet, just drop me an email with one of these files as an example, and we'll just add it to the readers. The benefit of having the readers is that you get a lot of more information than when you export it to an Excel file. And I'm talking here about the metadata. So what happens is, once you've captured your spectral information, these files, and if you put them into like a folder structure, this is a user-defined structure which we also ingest during data reading. So we capture the data structure, we insert the spectral data, and we automatically read the meta information from these input files. So like, it's best to have the raw output of the spectrometer, the original data files, because they contain most of the meta information. The next step is metadata augmentation. We've got this metadata editor tool, which makes it really straightforward to annotate your information with the metadata. There is a few also automated inserts where you can, once you've got a few kind of data in terms of time and location, then you can automatically calculate solar angles. You can also compute measurement supports and so on. So the goal has been to make it as painless as possible to add meta information. You can also, if you got metadata in an Excel sheet, which has like a common link, this can be like the file name or any other field that ties your spectral data to the metadata in this Excel sheet. This can be also read in an automated fashion and added to the metadata. In any case, no matter what you do, it just takes time. And data curation is something a lot of people don't like to do, but it's really worthwhile in the long run. So this histogram here shows what happens if you just use the standard file reading. You get something like 15 meta parameters from an ASD binary file, and then we take this further and we add a lot more, and we get to a mean of, let's say, about 35 to 40 meta parameters per spectrum. Interactive processing. So this is our tool for the reflectance calculation, and it can be done through this graphical user interface we wrote in MATLAB. It's got this component here on the left-hand side, which is a direct browsing capacity that connects to the spectral database. So wherever you click, it's just going to pull in the data. Then it shows you the data in various kind of displays and shows you also the final reflectance. And then it inserts that into the database again. So like in these, you see our structure we usually adopt here, which is like a campaign, and then or could be a target. In any case, you get like digital numbers, radiances that were corrected for jumps between detectors. That's something quite common in the ISD. And finally, also the reflectance. And all of these steps are created on the database and make it really easy to know how your data was processed. The data selection is based on metadata space queries. So the metadata space consists of all the meta information you entered. So like in these previous examples, like we've got 40 different parameters, we can, the best we could do is like constrain it in 40 different dimensions. And this is what this kind of cube shows, the intersect of those spectra that fulfill all these conditions you can define. These are the ones that are being selected. And you can do this with this graphical user interface. Once you've got it, you can also auto-generate code that is ready for use in MATLAB or R. The installation, so like we've got an online system. The only thing you need to install is the Java client. And then you can get an account on that online system. There is a variety of campaigns on there. We have a look later on what we've got. You can also use this web interface to interact with the system. You can, like as I said, this desktop client is the only software you need if you want to use the online system. It's based on Java. You need to have the right Java version. Java 8, I think, is what is required. And it runs on all different operating systems. And it can connect to any database, SPECCHIO database, where you've got the access points. We also got a virtual machine. This is if you want to have your database locally and you don't have to have an internet connection. You can essentially, this is the combined server and client in a box. And you can also, that's what I usually do for development. I've got my virtual machine running on my Mac, and then I'm using the Java client on the Mac, and it connects into the server which runs in the virtual machine. So this is actually quite a nice feature. Actually, the whole source code is online, so whoever wants to contribute to the code can do so by downloading these and asking to be a contributor. These are the list of servers and databases we've got currently online. By online, I mean accessible by the public. This one is hosted on our servers here at Uni Zurich. The productive system has got these 175,000 spectra. At this point, there's also a test system for obvious reasons. If people want to play with their data and they're not really useful data, use that one. Then there's a few ones that were for specific projects, particularly the Able and Swamp summer school data. There are on a specific instance here of a spectral database schema. Installing the client is fairly straightforward. There's the downloads on our web page. We currently got some issue with our web page certificate. We try to fix that in the next few days and weeks again. In any case, it still works, but you need to click a little bit more and accept safety security risk. And if you install it on Mac OS, it also integrates nicely. It looks like a Mac OS application. So now we'll have a little video which will play, and I'm just going to comment what's happening on the screen here. This goes to show how you actually start the SPECCHIO system. It pops up, and you can select some of your known data connections. It connects to the system. Then you can open the data browser. You can see all the data that's served by this system. This is our online system, so it's got a lot of campaign data we collected for the airborne campaigns we do. And you can go and select kind of single files, or you can select whole folders, and it'll select everything that's below these structures. You can go and generate reports. This is now a report for 30 spectra. You can start and click through these spectra there using these controls. This is all the meta information we've added here, so it's nicely documented data set. There is also like the different colors of blue and green and so on, shows if these things have been shared between several spectra. You can also upload field protocols, which is quite useful if you want to know who did it in the first place. Spectral plotting can be done here, quite simple. Let's see what else I had in mind. Yeah, you can also do file exports, currently CSV or NV spectral library files. And you can define whether you want to have this split into a header or body or not. It's now gonna export these files. Let's have a look at the file system. There they are. And it's now going to open, well, it actually opened numbers. And here we go. This is the body, and it contains the wavelengths and all the spectral data. And then here you've got the meta information, which is actually quite redundant in many cases. But anyway, you get one line per exported spectrum with all the meta information you've got in the system. just in case someone actually wants to have a comma-separated value file. I think in many cases, as I said, it's nicer to just keep it in the database. Yeah, and here you've got the whole body with all the like 2000 plus spectral bands. So that was the access through the graphical user interface. Now, I might actually skip this one. I've got one on programmatic access from MATLAB, but I think I've got that actually online and also as YouTube video. But if anyone's interested, I can also kind of point you to that video, because this is about like almost a quarter of an hour, where it just goes slowly through how you program the system, how it pulls in the data, and so on. So the final thing I want to show here is the example of the spectral ground control points, where these are the files we use to do calibration validation of airborne data. And so what we're going to see is the data structure and how this is actually being implemented. Again, this is our in-house system here. We now open the metadata editor. There is our ground control campaign with all the different missions. These missions are ordered by target, and each target has got these DNs, radiances, etc. Let's have a look at the radiances. There's again all the meta information. And now we're going to do a spectral plot, and we can zoom in on one of these problems I talked about earlier. This is the jump between the V-near and the sphere 1. This is the next thing we select here is the radiance jump corrected, which is also inserted into the database. There the jump is gone. And this processing automatically like keeps all the meta information from the previous step. On this jump corrected radiance, we can do a timeline exploration to see what happened here. So like the way we usually measure is we do by the reference measurements at the start of the experiment, then we do the target measurements. You can actually try and click on these points and it'll load the spectrum there in this other display. And these 30 target measurements are usually followed by 5 wide reference measurements. So that is why we see this kind of valley shape. You can also see that in the meta informations, like if you select the first spectrum that was collected. So here, basic target type has been set to spectral on. It is designated as a reference. We get to number 5 here. We see it changes to the target, and it's this kind of sports ground called tartan. Going to reflectances, we see that all the reflectance spectra are actually of the type target, and here the inserted reflectances. Yeah, they all share a common position. And again, the measurement protocols of the field have been scanned and put in as meta information here. And I think that is that. So this was essentially it. Remember, metadata is very important. It helps you in the long run. So try and go ahead and work on your meta information. And with that, we get to the questions. Thank you.